In the final part of today's lecture, I'll cover two applications of offline reinforcement learning methods on practical domains. So the first one is an application of offline RL into dialogue systems, where the goal is to be able to learn effective dialogue or conversation policies that understand the implicit human preferences in dialogue. And you want to do this via just offline RL. So there's a data set of conversations. And we want to be able to use that to essentially optimize for different notions of metrics such as empathy, the diversity of conversation, the fluency of the conversation, the fact that the chatbot or the robot says things that are related to the main subject matter that the human is saying, etc. And turns out that this paper actually applies policy constraint methods to this domain and obtains decent gains on such dialogue problems, where even the human rating of the conversation was found to be better when you apply offline RL methods rather than just plain supervised learning towards this scenario. Finally, I'll talk about an application that I worked on with some colleagues here at Berkeley, which aimed at applying offline RL methods to robotic settings, where you have a large amount of unlabeled robotic data, which is basically a robot interacting with a bunch of objects in the scene, etc. And now we want to be able to solve a particular task, a specific task, using just a lot of this prior data, as well as a very little bit of task-specific data. And this task-specific data has only sparse reward annotations, which means you get a 1 if you completed the task, so that's the indicator of what is a good behavior, and 0 otherwise. And there's only a very few ones in the task-specific data set, which is also very small. So it turns out that applying offline RL methods such as the conservative Q-learning method, which we discussed, you are able to utilize the unlabeled or general purpose data set along with the little bit of task data that you see to stitch together these behaviors that would end up solving the entire task that you care about. So you are able to, for instance, in this figure, the robot is able to open a drawer, or is able to, so it wants to open a drawer, so it's able to remove the obstruction in front of it, put it in the separate tray, then open the drawer, then do something with it, then pick up the object inside the drawer and put it somewhere else. In terms of sort of quantitative numbers, we find that such a method significantly outperforms all other prior methods, including sort of behavior cloning, sort of different ways of incorporating behavior cloning with actor critic methods, and so on. Finally, if you are interested, there are a lot of readings here, including a tutorial or a survey paper that we wrote earlier this year, as well as some resources for datasets or benchmarks and algorithms, as well as blog posts if you're interested in. Thank you for listening.